Hello everyone, welcome to Zenith Integral Academy. In today's class, we are going to be looking at a topic under instrumentation and control, and that is errors in measurement. And basically, the error in any measurement is the difference between the measured value and the true or actual value. Just like we have it in mathematics, that let's say the length of a book is 50 centimeter and a student measure it as 49.5 centimeter. The error that occurs in the student's measurement is going to be the actual length of the book minus initial length of the book, that is 50 centimeter minus 49.5 centimeter, and that is going to give me 0.5 centimeter. So this is what the error that occurs in the student's measurement is, 0.5 centimeter. That is just the normal, basic and fundamental aspect of error. Now, whenever we are calculating our value or you are carrying out an experiment, error tends to occur. And at the same time, when we are doing our calculation, if care is not taken, we might also likely be prone to errors. So let's quickly dive into the different classification of errors that we have. Number one classification of error is systematic or fixed error. And these are errors of constant or similar form that are resulting from improper conditions or procedures that are consistent in action. They include our calibration error, our human error, experimental errors, errors of techniques, and loading error. Similarly, we have another type of classification of error, which is the random or accidental error, and this include errors of judgment, variation of conditions and definition. The other type is illegitimate errors, which include blunders of mistake, computational errors, and chaotic error. Where I'm actually going to is in the quantitative analysis of error, the calculation aspect of error under instrumentation and control. So I'm going to be basically focused on that. And we are made to understand that most errors in measurement can be determined mathematically by the use of the branch of mathematics called partial differentiation. So I said under the quantitative analysis of error, we have basically, we use the knowledge of partial differentiation. So let me just quickly brief it, let us know what partial differentiation is all about. Let's assume that we have a function z to be equal to s squared y raised to power 3, and I want to find the differentiation of z with respect to s, and when I differentiate my z with respect to y as well, I can easily get the value of the z dx using partial differentiation, and similarly that of the z dy. So if I should differentiate z with respect to s, which is the z ds, I'm going to be having the 2 will come down, then you subtract 1 from the power using the normal general method, and that will give me 2 1, and I'm going to write my y back. Meaning that whenever you are differentiating a function with respect to a particular variable, all other variables are assumed to be constant. So if similarly, if I should differentiate my dz with respect to y, that is going to give me, what am I having here? Y cubed. So I'm going to be having 3 y squared, then you put your s squared back to it. So you can rearrange and write 3s squared y squared. So this is just a simple explanation on partial differentiation. So under quantitative analysis of error, they are of two types. One, we have error due to small increments. Error due to small increments. And the second one is error due to rate of change. And I'm going to be using the volume of a cylinder to explain this. Error due to small increment is basically and mostly represents and expressed in percentage, while this has to do with per seconds. Anytime you are doing your calculation and you are giving something like per seconds, then we are talking about error due to rate of change. Error due to small increments is always expressed most time in form of percentage. Now let's analyze these two things together. Now let's assume I have the volume of an open cylinder, and we know that the formula for the volume of an open cylinder, V, is equals to pi r square h. Now let me draw my cylinder. We have this. From here to here is the diameter of the cylinder. From the center to here I have my radius, and this is my height of the cylinder. This is the height of the cylinder. Now since I know that V is equals to pi r square h, now pi is a mathematical constant, r is the radius of the cylinder, and h is representing the height of the cylinder. So if I want to use the knowledge of partial differentiation to find the difference or the differential form that occur in terms of if I differentiate my volume with respect to my radius, and to find that of volume with respect to my height, I use partial differentiation. So you will say using partial differentiation. So I'm going to be having dv all over dr if I should differentiate my volume with respect to my r. And just like I explained earlier, so we are going to 2 is going to come down, then you subtract 1 from the power, just 1, then you write back your h. Similarly, we call this a. If I should differentiate my volume, my v, with respect to my h, that's going to give me pi r square, because it is raised to power 1 and you subtract 1 is going to be 0. Anything raised to power 0 is 1. So I'm going to be having this for that. So based on what I have here, let me use it to generate a formula for error due to small increments, and at the same time for error due to what? Rate of change. So if I want to do that, this is what I'm going to be having. For 1, so error due to small increments, which is always expressed in percentage. So I'm going to be having this formula. The error that will occur in the volume will now be dv all over dr dot dr plus dv all over dh dot dh. Sorry for using this, it's still the same thing, please. So this is what I'm going to be having as the formula I'm going to apply for error due to a small increment. You can see the radius can cancel this, I'm going to be having this back. The h can take care of this, I'm going to be having this back. Now if I want to generate a formula as well for error due to rate of change, this is what I'm going to be having. dv all over dt. I told you that error due to rate, when they say rate simply means, it's changing with time, per seconds. So dv dt is going to be dv all over dr dot dr all over dt plus dv all over dh dot dh all over dt. And similarly, this can still be written like this: dv all over dr dot dr all over dt plus dv all over dh dot dh all over dt. Is still the same thing. So this is what I'm going to be having. So in my next tutorial video, I'm going to be showing us how to calculate question on this. So this is the